A new AI creates endless, interactive worlds right on your desktop. This makes advanced simulations and games incredibly accessible. Let's get into it. Let's start with a featured paper. ABUT World 0, Infinite Interactive World Rollout on a Single Desktop GPU, by ABOT World Team from AMAP CV Lab Alibaba Group. ABUT World 0 presents a significant advancement in real-time, long-horizon interactive world modeling, enabling infinite interactive rollout on a single desktop GPU through a sophisticated data infrastructure and distillation pipeline. Here's a full breakdown.
Our system begins with a bidirectional teacher, where we use action control injection to adapt a pre-trained video generator into a controllable world model. This teacher then guides our auto-regressive causal student through a three-stage process, including teacher forcing and long forcing, to create a low-latency model for real-time interaction. To train this model, we condition it on various inputs, including keyboard actions and video tokens. These are sourced from a comprehensive data pipeline that involves agent-driven collection and automated annotation, which ensures the model learns from robust, high-quality data. Long forcing consistently outperforms causal forcing across all presented metrics. It achieves significantly higher HBSV3 aesthetic scores and much lower high saturation pixel ratios, perceptual blur scores, and patch repeat ratios.
Up next, our second paper out of 3. They'll verify. They just won't act. How authority framing and laundered code turn a trusted agentic CI/CD pipeline into an attack surface, by Johan Sidit from Centex Research. This paper uncovers a critical and underexplored security vulnerability in agentic LLM pipelines, demonstrating a novel attack vector that leverages authority framing and laundered code to exfiltrate secrets. Let's break down its key contributions.
Here we have our multi-agent CI/CD pipeline, which models a typical software development workflow. It starts with an external issue and moves through triage, a developer, a scanner, a reviewer, and finally an approver. Feeding into this pipeline is our attack, which begins as an external issue containing a seemingly benign feature request. The developer agent then translates this into what we call laundered code, which is submitted as a pull request. Next, to bypass the human-in-the-loop stages, the attack uses authority framing. You can see how the pull request is marked with pass and approve messages, which influences the downstream reviewer and approver agents. Ultimately, this leads to a systemic failure where the malicious code is deployed, resulting in secret exfiltration. The evaluation shows that because every content-based check, like the scanners, sees the code as clean, the pipeline's defenses are completely bypassed. The compromise rate varies significantly across the different configurations, ranging from a low of 5% for in/solo, in/chain, and t/solo, to a high of 55% for t/chain/off. This indicates that configurations involving off lead to a substantially higher compromise rate compared to the other methods.
Up next, our third paper out of 3, Reliability Scales Inversely. Bigger models compound mistakes faster via a hidden auto-regressive risk regime, by Kushal Chakraborty from Obviously Wrong, LLC. This paper introduces a novel theoretical framework and empirical evidence to explain why larger language models can exhibit reduced reliability despite increased capabilities, identifying a hidden auto-regressive risk regime that compounds mistakes. Let's break down its key contributions.
Looking at the top chart, we can see how this new analysis breaks down model error into 2 key components as model scale increases. The blue line shows the knowledge gap, which is like the model's inherent bias, decreasing with size, while the red line, knowledge degradation, represents compounding risk, which worryingly increases. The method demonstrates excellent control over variance, with the realized variance closely aligning with the target dose, indicating near-ideal performance. Additionally, the bias drift for all tested models remains remarkably low, staying far to the left of the critical barrier, signifying high accuracy and stability.
Those were the top papers. Now, let's zoom out. ArXiv received 582 new computer science papers across 57 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: ensuring safe and scalable AI, robust, efficient, and ethical AI, economics and optimization of autonomy, advanced mathematical methods for AI, automating and optimizing complex tasks. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, Please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.